In this video, I want to do a quick example to illustrate the difference between net area, which is what our Riemann sums give us, and total area. And in this example, we're going to use geometry and not Riemann sums to illustrate that difference. Let's start with net area, which is the area that our Riemann sum would give us if we used Riemann sums to approximate this area. And net area is equal to the area above the x-axis plus the area below the x-axis. Now we need to keep in mind that the area above the x-axis will be a positive value and the area below the x-axis will be a negative value. Let's start by calculating the area above the x-axis. That's the area that I've highlighted in yellow. This is the shape of a triangle. The area of a triangle is 1/2 base times height. The base of this triangle spans from x equals -1 to x equals 1. So the total length of the base is 2. And this triangle has a height of 1. So the area above the x-axis is 1. Now let's calculate the area below the x-axis. That means we'll be calculating the areas of the two triangles that you now see highlighted on the graph. The triangle on the left has a base of 1 and a height of 1. So 1/2 base times height gives us 1/2 times 1, which is 1/2. But we have to keep in mind that because this portion of the graph is below the x-axis, our area should be a negative value, because technically this triangle has a negative height, a height of -1. And we'll add to that the area of the triangle on the right. Well, this triangle has a base length of 1 unit and a height of -1. So that'll give us another negative area because this portion lies below the x-axis. So we'll have 1/2, 1 times -1, which again gives us -1/2. And -1/2 plus another -1/2 is -1. So our net area is 1 minus 1, which is 0. And because the net area is 0, that tells us that the area that lies above the x-axis is equal to the area that lies below the x-axis. So now let's talk about total area. And total area is the area that is the most applicable in the real world, because think about it, in the real world, we don't deal with shapes that have negative areas. To find the total area, we'll take the area above the x-axis and add that to the absolute value of the area below the x-axis. The reason we're taking the absolute value of the area below the x-axis is because we want our total area to be a positive value, just like an area would be in the real world. We've already done our area calculations, so we know the area above the x-axis is 1, and the area below the x-axis is -1. 1 plus the absolute value of -1 is 1 plus 1, or 2. So 2 is the total area bounded by the graph and the x-axis.